Hello, my name's Weiman Kwan, creator of the WMK Math channel. In this video, I am going to discuss how to solve equations. In this first part, I am specifically going to talk about solving 1- and 2-step equations. Here are the details of what is going to be explained. First, I am going to talk about the key ideas of solving an equation. Second, I am going to show how to solve 2-step equations. There are some that I am going to use equation manipulation rules only. There are others that I am going to use algebra rules and equation manipulation to solve the equation. Let's talk about key ideas of solving equations. The first idea is whatever we do to one side, we do to the other side. This rule is important because when manipulating equations, one must ensure that the equations remain balanced. It means that if the left side of the equation is added by 6, the right side of the equation must also be added by 6. The second idea is talking about solving equations. When a person is asked to solve an algebraic equation, the goal is to isolate x and find the actual number that the variable represents. Hence, the last line of any given equation should always be x equals something. The third idea is what type of manipulation one needs to get to the answer. This is the idea of opposites attract. Let's start with addition. What is the opposite of addition? It is subtraction. So when a person has an addition term and the person wants to get rid of that term, he or she uses subtraction to remove it. For example, if we have x plus 3, we should get rid of the plus 3 term. To remove this, we have to do minus 3 on both sides of the equation. So on the side with the plus 3 term, we have plus 3 minus 3, which gives 0. What happens if we have subtraction? We use the opposite operation of subtraction, which is addition. For example, if we have x minus 5, we should remove the minus 5 term by plus 5 on both sides of the equation. Let's look at multiplication. What is the opposite to multiplication? It is division. So if we have on one side 3x and we need to get rid of this times 3 term, what we do is divide both sides by 3. If one divides 3 times something by 3, it gives 1 of something remaining. Finally, there is division. The opposite of division is multiplication. If on one side we have x over 4 or x divides 4, to remove this divide 4 term, we multiply both sides by 4 and it gives x on one side. If these ideas are confusing, take a look at my previous video on Introduction to Equations for a detailed look on solving these one-step equations. What is the best way to start thinking about solving equations? Think of solving equations like a game. We have a friend known as variable x in the middle of the screen. However, this friend is surrounded by evil math operator bullies from all corners. The job of the mathematician is to manipulate this bully and free our variable x friend from these bullies. We can manipulate these bullies by using reverse psychology. To manipulate the addition bully, we can use subtraction. We can do the same thing for all the other math operator bullies. In some instances, we have to deal with only one bully. In other times, we have to deal with 2, 3, or even more bullies at the same time. It is easier to deal with one bully than 2 or more bullies. Now there are tricks in dealing with these bullies, and I am going to show how. Let's take a look at the first example here. In this case, we got 2x plus 3 equals 7. What do? First thing about equations is to identify where the variable term is located. We see that it is on the left side of the equation. We should try to isolate x on the left side. However, we can see that this x is multiplied by 2 and is also added by 3. Hence, there is a multiplication term and also an addition term. The general strategy when dealing with this case is that we deal with the addition or subtraction term first before dealing with the multiplication or division term. The first move is that we want to get rid of the plus 3 term on the left side. To do that, we use the idea of opposites attract and subtract 3 on the left side. Since we like to keep our equations balanced, we also have to subtract 3 on the right side. By simplifying this manipulation, the result is that there is 2x on the left side and 4 on the right side. This ends this first manipulation, and the result of this new equation is 2x equals 4. Now, the second manipulation is dealing with the multiplication term on the left side, which is 2x. To deal with this, we divide the left side by 2. To ensure balance of the equation, we also divide the right side by 2. After we simplify, the result is that x on the left side and 2 is on the right side. The final result after the second manipulation is x equals 2, and this equation is solved. Let's take a look at the second example of x divides 4 minus 5 equals 1. What do we do here? First, look at where the variable is. In this case, the variable is on the left side of the equation, in which the x term is divided by 2 and also subtracted by 5. There is a division and subtraction term here. Similar to the previous example, the same strategy can be applied here. Deal with the subtraction term first, and then deal with the division term second. The first manipulation is to remove the minus 5 term on the left side. To do that, we add 5 on the left side, and also 5 to the right side to balance the equation. When you simplify the left side, what is left is x divides 4, and on the right side, 6. This ends the first manipulation, and the resulting equation so far is x divides 4 equals 6. The next manipulation is to deal with the division term on the variable. To remove the divide by 4 term, you have to multiply the left side by 4. The right side is also multiplied by 4 to keep the equation balanced. Just a little side note, the way it is written with the brackets and the number, it means multiplication. When somebody has this scenario of 4, and then open brackets, and then a 6, and then close brackets, that is the same as having 4 times 6. Getting back to the equation, when one simplifies the left side, it results in x. And on the right side, we have 24. The last line we get is that x equals 24, which solves this equation. Let's take a look at the third example of x plus 3 minus 7 equals 14. What do we do here? First, let's take a look at where the variable is located. In this case, the variable is on the left side of the equation, which also has a plus 3 and a minus 7 term. In other words, there is an addition term and a subtraction term next to the variable. What do we do first? I've decided to try to remove the minus 7 term on the left side. To do so, I add 7 on the left side and also on the right side to keep the equation balanced. By simplifying both sides, the result is that I have x plus 3 on the left side and 21 on the right side. This results in the equation so far, x plus 3 equals 21. After taking a look at the new equation, the next move is to remove the plus 3 term on the left side. To do so, we can subtract 3 on the left side, but we also need to subtract 3 on the right side of the equation to remain balanced. This results in only x on the left side and 18 on the right side. Therefore, we have x equals 18, and this equation has been solved. Is there another way of solving this equation? Indeed, there is another method, and this time using some algebra rules. Let's start from the beginning again with our equation x plus 3 minus 7 equals 14. We also know that the answer is x equals 18, so I'm showing this anyways. So what are the options that we can do here? Let's take a look at that plus 3 and minus 7 on the left side of the equation. We can actually simplify these numbers by using integer rules. Technically speaking, algebra rules also include integer rules, fraction rules, decimal rules, and all the other math rules that affects how to manipulate algebra expression. So let's simplify the plus 3 minus 7. Using integer rules, the result of this is minus 4. So the plus 3 minus 7 is replaced by the minus 4, and this results in the equation being x minus 4 equals 14. The next manipulation we do is to add 4 on both sides, so we remove the minus 4 term on the left side. The ultimate result is the same as the previous method, which is x equals 18. If one encounters a case where there is 2 addition or subtraction term, that person can simplify those terms and continue to solve the equation. In this case, it is slightly faster to simplify first and then solve the equation than just simply manipulating the equation alone. Be careful that using algebra rules is not always the easier path in solving an equation. Let's take a look at the equation 2x divides 3 equals 12. The first method I am going to use to solve this equation is pure manipulation equation method only. So where do we start? Always start by identifying where the variable is located. In this case, the variable is located on the left side, in which it is affected by a multiplication and division term at the same time. It is the times 2 and then divided by 3. What do we do first? The ideal strategy here is to remove the division term first before dealing with the multiplication term. In theory, we could actually reverse the steps, but there's a good chance that there will be bad numbers appearing, especially when we're working with the dividing step. So let's look at our left side, and we see that on that side it's divided by 3. In response to that, we will multiply the left side by 3 to get rid of this divide 3 term. But because we're multiplying 3 on the left side, we also have to multiply 3 on the right side. The resulting equation is that on the left side, we have 2x remaining, and on the right side, we have 36. After the first manipulation, the result is 2x equals 36. From this step, the next thing we will do is to isolate x, and we have to deal with this times 2 term. To remove this, we need to divide the left side by 2, and we also have to divide the right side by 2 to keep the equation balanced. This results in the left side as being x, and on the right side as being 18. So the solution we got is x equals 18. Now we are going to revisit example 4 again, but with algebra rules. This is going to be really tough stuff and hard to follow. If you are confident about understanding this, continue on. Otherwise, I would suggest you skip to the summary section of this video. Consider this as a warning. Let's take a look at the equation 2x divides 3 equals 12 again. This time we will hide the answer, which we know is x equals 18. Now, in this method, we are going to use algebraic rules and fraction manipulation to get to the answer. Listen carefully, or else it might be difficult to understand. We see that on the variable term, which is on the left side, we see that it is multiplied by 2 and divided by 3. Since it is using multiplication and division, and it's on a single algebraic term, we can actually treat these operations as a single term. In other words, the 2x divided by 3 can be thought of as being 2/3 x instead. If you don't understand this, make sure to check out the algebra rules. Anyways, as a result of this algebraic manipulation, we get the equation 2/3 x equals 12, where 2/3 is multiplied by x. What do we do to isolate x? We multiply the reciprocal fraction 3/2 to the left side, and if we do that, we also have to multiply the right side by 3/2 to balance the equation. Let's see what's actually happening with the left side and the right side in detail. So let's start with the left side. So effectively we have 3/2 times 2/3 on the left side. If we recall algebra rules, when you multiply any number by an algebraic term, only the number portion multiplies itself and the variable remains as part of the answer. So if we are multiplying 3/2 by 2/3, it gives 6/6. The variable remains, so the answer so far is 6/6x. However, 6/6 is equal to 1. So ultimately, on the left side, we only have x. On the right side, we have 3/2 times 12. You can think of 12 as being 12 wholes, or 12/1. If you think about it that way, then it becomes a fraction multiplication where we have 3/2 times 12/1. This gives 36/2. If we simplify this fraction, it becomes 18/1, or simply 18 wholes, which gives 18. Hence, we arrive at the final answer of x equals 18, like the previous example. This method of solving the equation is much tougher than the double manipulation we did previously. One needs to understand a lot of math and understanding all the rules of math to really use this method effectively. Let's review the key ideas about solving two-step equations and how these ideas can help you solve some two-step equations. Generally speaking, if there are two-step equations, you really need two manipulations to get to the final answer. These manipulations can be a combination of addition, subtraction, multiplication, and division. Keep in mind that with one-step equation, there is generally one way to solve the equation. However, with two-step equations, there can be multiple ways to solve the equation. This is absolutely fine as long as all the math rules, especially the manipulation of equation rules, are followed properly. Also note that even if there are multiple paths to get to the answer, the final answer should ultimately be the same, regardless of what path you used. Finally, it can be observed that not all paths are made equal, and they're not equally easy. Just take a look at the previous example, and you know what I'm talking about. Thank you for watching this video on solving equations part 1. If you have suggestions or comments, feel free to write them below. You can also email me at waymanquant87@gmail.com. Thanks for watching this WMK Math Channel video. Bye bye.